In this course, we'll be learning about ANSYS, a tool widely used in the industry. This course features 45 hours of classroom sessions, 150 hours of practical sessions, topic-wise online tests, 45 hours of industry-oriented project, and special sessions for interview preparations. In Module 1, we'll be looking into geometry preparation and meshing techniques using ANSYS. You will learn part modeling techniques, under which you'll have 2D sketching, creating planes, sketch instances. You'll learn shared topologies, cleanup, connect and repair operations, topology alignment, and model estimation methods. We'll then move on to meshing, element type definitions, which will consist of 3D mesh generation, mesh control techniques, size and shape check. We'll have workflow in CAE simulations, and at the end of the course you'll have assignments and evaluations on geometry and meshing. In Module 2, we'll be looking into structural simulations using ANSYS. We'll learn structural analysis of aero and automotive systems, industrial approach to design and validation, introduction to FEA, introduction to strength of materials, linear static analysis, both theory and practice, under which we will learn design validation of drive shaft of an LCV truck using structural analysis, failure mode prediction of a pressure vessel using FE analysis with analytical correlation, estimation of load carrying capacity of a lower control arm of a heavy truck using simulations. We'll then move on to results processing and interpretation, and finally results correlations and documentation. In Module 3, we'll be looking into advanced geometry and meshing techniques using ANSYS. We will learn 2D meshing techniques for thin parts, under which you will have mid-surface extraction and meshing of plastic components, mid-surface extraction and meshing of BIW sheet metal components like chassis, etc. We'll then move on to 1D meshing techniques, introduction to 1D elements, such as FE modeling of SAE Baha frame using 1D elements, assembly meshing techniques, under which you'll have connections such as modeling spot welds, bolts, etc., contacts, linear and bonded contact modeling, FE modeling of a shaft using text files. You'll also be introduced to MPC and remote loading, assembly meshing of a wing box with shear clips using bolts, and finally you will learn mesh generation techniques for stress or durability analysis. In Module 4, we'll be looking into thermal and dynamic analysis using ANSYS. Under this, you will learn normal modes of vibration, under which you'll have solution methodology, eigenvalue and eigenvector, and Langsource method, and introduction to vibrations. You will then be introduced to modal analysis, where you will learn vibration analysis of a rotor, modal analysis of a disc brake. You will then move on to introduction to pre-stressed analysis. We will run a pre-stressed modal analysis of a turbine blade. You will later be introduced to frequency response analysis, under which you will learn harmonic analysis of a rotor system. Finally, you will have introduction to thermal analysis, under which you will have thermal analysis, conduction, heat, and transfer in a friction ring. In Module 5, we will be looking into assembly modeling and meshing using ANSYS. You will be introduced to solid editing, under which you will have creating mappable solids for 3D mesh. Here you will be introduced to sweep meshing, slicing solid bodies, local sizing controls for face, edge and body, mesh controls for mapped faces, multi-zone meshing, mesh automation, 3D hexa meshing techniques such as sphere, T-pipe, blocks with cuts, 3D hexa meshing of door hinge bracket, and 3D hexa meshing of a control arm. We'll then move on to brick meshing of a solenoid body. You will later be introduced to CFD meshing. Under this, you will do the CFD meshing of an exhaust manifold. You will learn how to export case files for ANSYS FLUENT solvers. In Module 6, you will learn buckling and non-linear analysis using ANSYS. You will have introduction to nonlinear analysis, solution methodologies for nonlinear analysis, types of nonlinearities, nonlinear contact analysis, under which you will have nonlinear contact analysis of fuel tank bracket on a chassis, and modeling contact pairs for a typical 3D bolted joint on a flange. You later move on to large displacement analysis, under which you'll have geometric nonlinear analysis, bilinear plastic analysis of a subassembly of a chassis. We'll then move on to introduction to buckling analysis, analytical solutions of buckling of columns, prediction of buckling in a truss using linear buckling analysis, preventing the collapse of a piping system using linear buckling analysis. You'll also have a value-added module free of cost, which will consist of meshing analysis using HyperMesh and Radioss, which is a taste of NASTRAN. Under this, you'll be introduced to HyperMesh and Radioss. You'll learn importing geometry, CAD and GUI, geometry preparation, model evaluation, topology cleanup operation for automotive components, 2D meshing, quality parameters, mesh quality checking and correction, 3D meshing, introduction to 3D elements, volumetric tetrameshing, refining tetramesh, linear static analysis of control arm, introduction to LSA, introduction to Radioss bulk data entry, running analysis, post-processing, normal mode analysis of machine frame, introduction of normal mode analysis, solution process for normal mode analysis, analysis setting and solving, and extracting various modes of vibration.